Hey everyone, thanks for stopping back to Pete's Garage. Well, to finish up this video series with this Cobra engine, we're going to dyno test it. Now, you may be thinking, why would it be necessary to dyno test your engine before you put it in? And there are many reasons why you should do it. First of all, you want to make sure that it doesn't leak. You put it on a dyno, check to make sure there's no leaks, no problems, no major malfunctions, because the last thing you want to do is put it in the vehicle or put it in your car, start it up, and you have an oil leak. That's number one. Number two, when you put your engine in your car without dyno testing it, you're never really sure if it's tuned properly. That includes carburetors, not just fuel injection, but carburetors. It's tough to tune. You have to choose air-fuel mixture ratios. Those have to be all set, changing jets, changing carburetors, all that stuff, and it's really difficult, if not impossible, to do by just throwing it in to your car, number one. That's number two. Number three, if you're using a solid tappet, solid lifter cam, and you don't break it in properly, you're going to waste a lot of money. You're going to blow out your cam, and then you're going to waste all that money on your parts and everything. So using a dyno is cheap insurance to make sure that it's perfect before you put it in the car. Eliminates a lot of headaches, a lot of nightmares. Now, if you're going to choose a dyno, if you have choices, there's a lot of things you should do in choosing your dyno. I'm lucky I have a great dyno guy real close to me, Joe Hetz. He's phenomenal. He's been around for a long time. He has experience with all types of engines, gas, propane, racing engines, over thousands of horsepowers down to, he just said, my Studebaker engine. So he is a great guy to work with and very helpful, very friendly. So let's start with that. When you're choosing a dyno guy, if you only have one choice, you only have one choice. But if you have several choices, like me, I have within a 50-mile radius, a 2-hour drive, I might have maybe 5 or 6 places to choose from, and they're all different because they all specialize, they all have specialties in different things. So first of all, you want to call them up, go talk to them, see how personable they are. Just like with your machine shop, when we talked about machining parts or machining components for your engine, your dyno guy, you got to work with the guy because you want to interview him, talk to him, stop and visit, see if you can watch him do a dyno test, and watch what he does, watch how he goes about doing his job, watch how he goes about his work, the interaction with the customer, and know that you're going to be comfortable working with him because it's a collaboration. There's going to be it's pretty expensive. It can get pricey. Some guys charge per an hour. Some dynos charge for a day, and it can range from $500 to $1,000 for your dyno time. So if you're putting that much money into your dyno test, you want to make sure that it's going to be a great experience and you're going to walk out with a rock-solid engine that's going to last a long time. So talk to the guy. Talk to the person just like you would talk to your machine shop. Not only talking to maybe the guy who owns the dyno, you actually want to talk to the operator, the dyno operator who's actually going to be doing the testing, because you're going to want to know what? A lot of things. Can you help? Can I be there? Can I help? It's my engine. Or if this is your first time doing a dyno test, I know it's kind of intimidating, but don't be. They're there to help you. They're only successful if you're successful. They don't want to have engines going out of there that don't run right, and then when they say, well, where'd you get it tuned, and you tell them where you got it tuned, and they don't want a bad name. They want it perfect when they leave the dyno. So ask if you can help. If you can help, you might have to bring special tools depending on the engine you have. And you want to discuss your goals. Discussing your goals with the dyno guy is important, or the dyno operator. It's important because that's what determines how you're going to spend your time. For example, you might be trying to choose the right carburetor for your engine. So you're going to bring all the carburetors with you. It's going to take time to swap, and you might want to do it yourself. So your goal is to find the perfect carburetor. Or, like this, my Cobra motor here, it's got the Gen 7 computer for the fuel injection, and Joe's very familiar with the computer software. He's familiar with tuning. He's got a bunch of these systems running, so he knows how to tune this particular engine. So is your goal tuning? Are you trying to tune and get the perfect tune for a certain RPM range? Are you got a dirt track car? Well, whatever it is, discuss your goals and discuss how you're going to spend your time, because it is expensive. Then, know the specs of your engine inside out. Know your cam specs, your rotation at 50. You want to know all that stuff that's very specific to your engine, so when you have a problem or you're trying to fix something, that you understand where to look. And knowing the specs of your engine we'll kind of we'll let the dyno operator know exactly what the limits are of the engine are and what they can help with and what they might not be able to help with. So know the specs of your engine inside out. Also, if you have headers, take the headers with you. Even though the dyno will have a bunch of headers, stock headers, most likely for your engine, they might not be the exact same ones that you're going to be using, and it could make a difference. So if they'll let you bring your own headers, bring your own headers. Otherwise, you might have to make adjustments when you're done. Also, bring any extra parts. Bring all the parts that you're going to be using when you put the engine in the vehicle. The air cleaner, the headers, the fuel pump, the fuel system, all the stuff that you're going to be using, you want to put that as much as you can on the dyno to prove it all out, to make sure it works as a system. You're not just tuning the engine, you have components around the engine that have to support it, and they have to work as well. So you want to make sure that you have the right components. So you bring everything with you. You get ready, make a transport device. If you don't have a cradle, most of the time the dyno shop will have a cradle they can lend you to bring the engine to the dyno shop. I made one for this engine just because I had the stuff, and I made one, and I use one a lot, so I had one to take it back for. So get a cradle, get a lift, make sure that you have the time, know when they're going to start. You get there ahead of time to unload it, have it ready for the dyno operator because their time is important. As soon as they're on the clock, if you're still unloading your engine, you're wasting your money unloading your engine. You want to get there, ready to roll, put it on the dyno, and start testing as fast as you can. Now, part of the test, or part of your dyno test, will be breaking your engine, breaking in the cam. So let's go talk about, real quick before we test this engine, let's talk about oils, braking procedures for your cams, and what you're going to end up doing for breaking in the engine. Now we'll talk about the first start and break-in, especially if you're going to do it on the dyno. Now the Cobra engine, if you recall, if you've been following the series from way back when I started it, I had problems the first couple times I dynoed it. It was sucking oil into the intake manifold, and I think I had that problem corrected. I did a few things. The oil holes between the head, the return holes between the head, the aftermarket head, racing head, service heads, into the standard block, those holes were kind of offset, so I don't think the oil was returning properly, number one. And I found out that the intake manifold was not perfectly square, so I had to machine that to get that square. And a couple of other little things I did to make sure that I took care of the problem, so hopefully that took care of the problem, and we'll see. But this is a roller engine. It's got a roller cam in it with roller lifters, so I don't have to worry about break-in. But if you're going to break in, number one, most important thing, if you're breaking in, the cam. That's what you're breaking in first, is the cam. It's got to run at least 15 to 20 minutes, 1500 to 2000 RPM, okay? So you're going to start it up, get some timing set right away, get it up to 1500 RPM, and keep it there, hold it there for at least 15 to 20 minutes. Now, if you're using a performance cam that requires double or triple valve springs, you have to remove the inner valve springs first. If you don't, you're going to wipe out the cam, you're going to start all over again. So the dyno guy should help you out. Once again, discussing your goals ahead of time, you should know exactly how you're going to do this and the process you're going to go through, so you can bring it there with the springs removed, and then halfway through you could either take it off, or if you got the time, if you can do it, change the valve springs and put the springs on there, put the inner springs in later. So taking the inner springs out, that is a must. So you're going to break it in first. Like I said, the roller cams, you don't need really a break-in, nor do you need zinc in the oil. But if you're running a flat tappet cam, all flat tappet cams need to be broken in, which means they have to have both. They have to have a break-in period, and they have to have zinc in the oil. And as long as we're talking about oil, you're going to go to your dyno, you're going to break it in, start it up first, and you want to have a good break-in oil. The oil should have zinc in it. Even though this is a roller motor with a roller lifter, roller cam, I still using the zinc in the oil. If you don't have oil with zinc in it, you can get a zinc additive, but you can get good break-in oils. You don't want to do not use a non-detergent oil. There's a myth that you need detergent in there to set the rings, but rings do not set from detergent. Rings set from heat and load. That's how you seat the rings. And you're not going to do that on a dyno unless the guy's going to help you do that. That'll happen on the road when you get it in. So you need like a 15W40 to maybe a 2050 oil, a good break-in oil. And there's many brands, break-in oils. You could use the Lucas Amsoil, Royal Purple. I'm using Brad Penn with the zinc in it, racing oil, just to make sure that it's broken in properly for the rest of the motor. and you should do that. You should not use a cheap oil. Cheap oil is going to be a disaster for you, especially when breaking in a flat tappet cam. So keep that in mind. Then when you're done breaking it in, if you put it on a dyno, now you're going to remember you're going to have it on dyno. You're going to race it up to 1500, 2000 RPM. It's going to generate a lot of heat. So you want to make sure that you have the guy. They're going to be familiar with this, but you might want to have a hose handy or something to cool down the water source because it's going to heat up. It's going to heat up in 15 to 20 minutes. So after you break it in, after you're done, you're going to reinstall your valve springs. That's when you're going to start doing your tuning. Then you're going to do some pull. You do some pulls on it first, and then put the springs in. Then that's when you're going to start doing the tuning. You're going to be tuning your carburetor, jetting, the fuel injection, whatever you're doing. That's when you start doing your tuning. Now, again, load and heat set the rings. There's kind of a myth that drive it easy for the first 500 miles, cruise at 65 miles an hour just to seat the rings. That's not really true. If you do that, all you're going to do is put a glaze on the cylinder walls, and then the rings they'll never seat. You'll have leakage forever. So the idea is like if you can go uphill, punch it at 65 and then let off, and then get up to 65 and punch it and let off. So putting it under load, letting the load off, and heating it up, that's how you seat your rings. Okay? Now, when you're done with the dyno test and braking, you want to make sure you change your oil filter and your oil, because after breaking it in, all those fine particles that were there that help seat the parts, those will now be in the oil, and you want to start in your car with a fresh oil filter and fresh oil. Now we're going to go and tune this engine. We're going to take it over to the dyno and run it and see how we do. I got some pictures I'll show you. I'll go through I'll show you a dyno pull, and first we got to do some prep. Can't forget that. I got to do some prep before I take it over to the dyno. Then we'll take it. I'll show you some prep steps, and at the end of the video, I've gotten a lot of questions about what particular parts are in this engine. So I will, in the credits part at the end, I'll put a complete list of all the parts with the part numbers of the important things like the block, crank, rods, pistons, the heads, springs, seats, the valves, the cam that I'm using, the lifters, the rocker arms. Those are the most important parts, and then I'll throw in the fuel injection, but that's just a matter of the throttle body and the computer. So if you're using a carburetor, it'll be a little different, but at least you'll know the internal components I got to get what I put in there to get the performance we're going to get out of that. So let's go through some pre-dyno steps you should go through. We'll complete those. We'll dyno the engine, and we'll see how it turns out. Okay. Now, one of the things you want to do is make sure you turn the oil pump over, get oil throughout the entire engine, and make sure that you have oil pressure, because that's going to be really important. So what I'm going to do is I'm going to take off my distributor cap, and you want to turn the engine over to make sure you know which way the rotor is turning. Sometimes the rotor turns counterclockwise, sometimes it turns clockwise. If it turns counterclockwise, that's what direction your oil pump is going to turn. Okay? So now that I know this turns counterclockwise, I'm going to take out my distributor, pull this out gently, and I have all the electronics hooked up, so I'm just going to set that off to the side, and of course all my wires here, right? Okay, so I'm going to go down inside there, and what I have is a drill motor with a socket extension on there, and I have the socket taped on there, because the last thing you want is to have the socket fall off and go inside your engine. Okay. Okay. Now, what I'm going to do is I'm going to turn this over for a couple minutes, and I'm going to watch a couple things here. You see, I have this gauge down here. This gauge, and when I turn this over, I should have oil pressure right away. Okay. See the gauge jump up? So I know I have oil pressure. So what I can do now is turn this off. And I can see oil in the front of the engine. That means I've got oil from the back all the way up to the front. Now what I'm going to do is I'm going to turn the engine over by hand, and I'm going to turn a crankshaft just to rotate it 90 degrees just so I can turn the bearings and make sure that it's lubricated all the way around. I'll do that 4 times. Okay, now I have the engine turned all the way over back to top dead center for cylinder number 1, and I have these pieces of tape on here just to make it easy for timing when we're timing it, since my damper here is silver and you can't really see the numbers on there. So I just got some tape on there so I can see the 0 is the black and then 10 degrees for every one of those red lines. I have it back to 0. And remember, when you get number 1 to top dead center, it has to be at a compression stroke. That way you know number 1 for the distributor pointing is back to top dead center. And I'll give it one last turn, make sure I still have oil pressure after turning it over. Oil pressure is good. Now I can put my distributor back in, and I have to make sure, when I do, that my rotor goes back for number 1, pointing at the number 1 position on the distributor cap, which is over this direction. So sometimes it takes a couple shots and you want to make sure it's fully seated. And the reason it doesn't fully seat is because the rod for the oil pump is still turned a little bit. So what I'm going to do is I'm going to go down there like this and just turn it a little bit by hand. Drop this back in here nice and gently. So see how number 1 is pointing too much that direction. Actually, let me see if we get out here. Yep, it's too far. Turn a little bit more. Turn a little bit at a time. There we go. All right, number 1 is pointing that direction, and I'm all set. I can put my cap back on. I have my distributor clamp back in place. Now I can remove my gauge here because the dyno guy is going to hook up right to that oil port for his own oil pressure sensor. So I can take that off. Of course, you want to go through and check all your linkages. Make sure everything moves nice and free. Like these wires are kind of in the way here, but that's not going to be a big deal. This is just temporary until I get the dyno test done. So those will not be in the way when I get this harness won't be in that way when I put it inside the vehicle. That'll be different. So at least all 8 of my butterflies are opened up nice and smooth. I looked at all my connections, checked all the bolts, make sure nothing's loose there. And the other thing I want to do is I want to make sure that everywhere I have a ground wire hooked up, that I have good continuity to the ground. So I have the clip on for my voltmeter on the ground of the engine. I'm just going to check I have continuity there for this ground wire. I got a ground wire back here. I got good continuity. I got good continuity and continuity. Okay, so I'm just checking to make sure that I don't have a ground wire hooked up somewhere where it's not going to end up going to ground, and we go to start it and we have a problem. So now I got a good ground. All my connections, all my linkages are nice and loose. I checked all my vacuum routing hoses. Those are all good. Everything's solid all the way around. And I checked my fuel connection back here. This will be where the fuel connection goes on for the fuel pump. My regulator, everything seems to be solid. So I got it all oiled up. My distributor's all set. The timing is very close to where it should be. Got my clamp back on. The wires are ready to roll. My linkages are free. Everything looks like it's ready to roll. So now I can put it on a truck, take it over to dyno, and let's run it. Now this part I'm just going to do with pictures because it's really loud in the dyno room with that fan blowing, air, and all the pumps running. But it took about 2 hours to get this all bolted up. Because it's an EFI engine, you can see the computer sitting, the ECM sitting behind the engine. All the sensors are hooked up. There's no thermostat in here, so the coolant flows straight through. And all of the electronics that are hooked up, including the O2 sensors, hooked up through all those wires going to that box, black box behind the engine. Right here, this is what we're tuning up. We have 2 computers. The first computer is controlling the ECM for the Gen 7, the XL Gen 7. And what we did is we ran it a few times, and we had to get all these settings correct. When you run it, all these electronic sensors obviously move as the engine's running. But we're looking at all the different things that are involved with running the engine, and all of the sensors and all of the maps. And this is how you basically tune the engine when it's running.
There's a separate computer that runs the dyno test itself, and this is on the dynamometer. This is where you start the test, you run it up to RPM, and it records every tenth of a second. It records data points, and it has temperature for all the cylinders, water temp, oil temp. Everything you see there is logged in, and then when the test is done, you can print it out and you look at it. Then you adjust the fuel, and if you have a carburetor, you adjust your jets. So whatever settings are available, you adjust them based on the test. For this computer, we adjusted the data map. The data map here shows how much fuel there is compared when at a certain manifold pressure and certain RPM, and you're trying to set up the optimum fuel flow so you have about between 13.5 roughly to 14 air to fuel mixture on all the cylinders individually throughout the entire RPM range all the way up to 6,000 under load. That's what this map is for. So here's the dyno sheet from the final pull. We made 478 horsepower at 5,700 RPM and 441 foot-pounds of torque at 5,000. On the right, you can see we left the air-fuel mixture fairly rich. We didn't go all the way up to 13 or 14.7. We left it under 13. We didn't want to run it too lean. It only got over 13 for a small RPM range, but you can see it ran very well. The couple things that are very important when you dyno test your engine. I see at the top there, the temperature, ambient temperature was 71 degrees. Humidity was 36. It was actually raining when we did this, so that there was a lot of moisture in the air. Barometric pressure was 29.5, with the air density being 106. That is important when you're tuning your engine. It does have a big effect on it. We had 36 degrees of actual timing, which was 22 adjusted on the computer, and our test range was 3,000 to 6,000 RPM. You can see it ran very well throughout the entire range.
So there you have it, guys. Successful dyno test, finally. The engine's all done, ready to put in the vehicle. The goal for this engine was 500 horsepower, came close at 478. We could have got there a little bit more, spent more time tuning, putting more fuel to the injectors, etc., but we didn't want to play around anymore because when I put it in the vehicle, it's going to have different headers, the exhaust is going to be different. When it's in there, I can tune a little bit more. But I forgot to leave out a very important part. Fuel. When you go to the dyno, you're going to have to take your gasoline with you. This ran on 93 octane pump gas. It was a 10% ethanol fuel, and that's probably most likely to be running in the car when I'm driving it. So you want to take the fuel with you that you're going to most likely be using or filling up with when you go and fill your car. I took a 5-gallon can. If you go buy a brand new 5-gallon can to fill it up, make sure you rinse it out. Don't just take it from the store and go fill it up because there'll be garbage inside. Rinse it out, then fill it up. We ran this for roughly, there's probably total engine time, maybe 45 minutes. Went through 3 gallons of gas. So you're going to go through gas if you're going to spend some time on a dyno. Total time was 4.5 hours, and it worked out great. Joe did a great job. We had a lot of fun. Talked about old cars. And when everything goes well, you have a lot of fun. And we had a lot of fun. I think we did 7 or 8 total pulls. And everything worked out great. Really happy with that. Now I promised you a list. The list will be coming up at the end here of all the parts that are inside. I appreciate all your comments. I appreciate all you guys who watched the whole video series and left comments and sent me text messages and talked back and forth. I really appreciate it. Thank you very much. And thanks for stopping by Pete's Garage.